Alright, hey everyone, welcome to the 7.4 Writing Equations in Two Variables video. Alright, so what is an equation in two variables? Well, it's just an equation that represents two different quantities that change in relationship to one another. Most equations that we end up writing really are equations in two variables because we always have things that affect another thing. Okay, if I have spent this much money, how much do I have left over? Both of those can be variables. So this is an example. We got y equals 3x. We got two different variables there. 4x plus 5y equals 20, or p equals 4b minus 1. So two variables in all of those. Now let's talk about a solution. Okay, so a solution to an equation in two variables is really an ordered pair. Okay, so ordered pair, that's key because we talk about ordered pairs in terms of x and y. That, when you plug it into the equation, produces a true statement. Okay, so what we're going to do here is we're going to test some ordered pairs on this equation to see if these ordered pairs are solutions. Now remember that the 4, like for this point, the 4 and the 9. The 4 is the x, 9 is the y. And so I'm going to put the x there, and the, I'm going to put the 4 there, and the 9 there, and then I'm going to rewrite. So it's going to be now 9 equals 4x means 4 times x, so now it's 4 times 4 plus 2. And we're going to put a little question mark because we're going to see, does that give us a true statement? So 9 equals, what's 4 times 4? It's 16 plus 2. So is 9 equal to 16 plus 2? That's 18. Now, so that doesn't work. So what do we know? That is not a solution. Let's plug in 522. Same kind of thing. Y equals 4x plus 2. And so, again, put the 5 where the x goes and the 22 where the y goes. So 22 equals, that's a 4, sorry. 4 times 5 plus 2. So 22, does 22 equal 20 plus 2? Well, last time I checked, yeah, 20 plus 2 is 22. So what does that mean? It means 522 is a solution of that equation in two variables. Alright, so when we have two variables, we have what's called an independent and a dependent variable, okay? So the independent variable is the variable representing a quantity that can change freely, okay? So, you know, an example of that would be I'm going on a vacation, and I'm going to spend $5 each week on souvenirs, or $5 a day. Well, what's the independent variable? Well, it's the amount of days that go by. Okay, that's going to change freely. It's Monday, then it's Tuesday, then it's Wednesday. But what changes based on the days that go by is the dependent variable, which is a variable representing a quantity that depends on the other variable. So what would that be in our little vacation spending money situation? Well, that would be the amount of money you have left, right? The amount of money you have left depends on the number of days that have gone by that you've been spending money. Okay, so another example would be the amount of money you make at your job depends on how many hours you work. So you choose to work as many hours as you like. So what's the independent variable there, and what's the dependent? Pause the video, see if you can figure it out, and play when you're done. Alright, so hopefully you got these answers, and that is the independent variable is the hours you choose to work. Now that makes sense, right? Independent. You think about like Independence Day, where we celebrate the freedom, the choice we have in America, right? So you independently choose to work as many hours as you want, or maybe you have a set schedule, but you got to go into work, right? So you're kind of making that choice. But what happens as a result of you making money? A result of you working is you make money. So the amount of money you make depends on the independent variable, which is the amount of hours that you work. Alright, so let's do this little problem here. A gallon of milk contains 128 fluid ounces. Every time you pour a glass, you end up pouring 8 ounces out. So the following equation tells us the amount of milk left, and we're going to use y for that part, left in the jug after x pours. Okay, so I wrote y equals 128 minus 8x. Why does that make sense? Well, let's think. First of all, they said the following equation represents the amount of milk left in the jug. Okay, so after, okay, so that tells us that what comes before that is going to be affected by what comes after that word after. So the amount of milk left is a result of, well, starting with 128 ounces and pouring out or subtracting from that 128 8 ounces every time you pour, right? So think about it. It needs kind of common sense. If I have 128 ounces and I pour out 1 glass, well, that 1 glass is 8 ounces. So it'd be 128 minus 8, or otherwise known as 8 times 1, because it was 1 glass. So let's label our independence and dependence. What's the independent variable here? Well, let's think. What is the free? I have this gallon of milk. I can freely choose to do what? Well, pour glasses, right? So I would say the glasses poured. What's the dependent? Well, the dependent is dependent on this. So when I pour glasses of milk, what happens? I lose milk, right? So the amount of milk I have left is dependent upon the amount of pours I pour, amount of glasses I pour. So milk left, okay? So now let's answer this question. How many ounces of milk are left in the jug after 7 pours? So we're going to use this equation to figure that out. Okay, so I'm going to rewrite it. And let's see, how many ounces of our milk are left? So this equation tells us the amount of milk left, y. So y is the amount of ounces, so we're looking for how many ounces of milk are left, so we're looking for y after 7 pours. Well, we know x stood for pours, right? So I'm going to take that 7 and put that where the x is. So now it's y equals 128 minus 8 times 7. Okay, now order of operations says I've got to do that part first. So what is 8 times 7? 56. All right, and then if you just kind of do that last part and you do 128 minus 56, you end up with 72, and that's ounces left over. Okay, and then we need to remember that, we talked about solutions to equations in 2 variables not being just one number but 2, like an ordered pair. So what is our ordered pair answer for this one? Well, let's think. X and Y, okay? And we said, let's see, how many ounces of milk are left after 7 pours? Well, pours was X, so we're going to put the 7 there. But when we poured out 7 glasses, what ended up happening to our Y? Our Y ended up being 72. Okay, so 7 comma 72 would be our answer here. All right, so during a normal weightlifting routine, you burn 250 calories. But when you decide to also ride the stationary bike, you burn 10 calories for every minute that you ride. Write an equation that represents the total calories burned during a workout. Notice I don't say how many minutes you ride, okay, on the bike, but we do know what is constant is that you burn 250 calories when you lift. So this assumes you're going to lift, and then maybe you're going to ride, maybe not. But I think we can build an equation that represents both. Now, what I'm going to do is leave you with this, give it a shot, bring your answer to class, and we will discuss it. So thank you guys for hanging with it. I will see you in class.